Good afternoon. In the last class, we have seen back propagation training algorithm with numerical example, and in that part one video, I have explained only half of the back propagation. So in today's class, we'll see the remaining numerical example while back propagating how the weights will be adjusted. That we'll see. So in the previous class, we have seen only how W5, W6, W8, W7 weights are updated from output to hidden layer. Output to hidden layer corresponding weights are W5, W6, W7, W8. How those weights will be adjusted, that's what we have seen in the previous class with these slides. So in today's session, we'll see how the during the back propagation, how the weights from hidden layer to input layer. Those are W1, W2, W3, W4 as shown in the figure will be updated. So this is continuous process. So weights will be updated in the forward propagation. We'll calculate the error at the end of the output neurons. That is output at the O1, output at the O2 will give the E total. E total is equal to EO1 plus EO2. EO1 will be is nothing. EO1 is nothing but target minus actual output. EO2 is nothing but target minus actual output at the O2. So based on that, we'll calculate the error. So again, we'll back propagate those errors and to update the corresponding weights at the between the hidden layer to output layer as well as between the input layer to hidden layer. So now weight will be adjusted. Again, we'll get the new error values. Again, back propagation. Again, error will be adjusted. Again, it will be the new error. So it is continuous process. That error, it will be maybe 1,000 times, 10,000 times. So we need to set some limit to that error. That is nothing but some error del e value. For example, if error is within certain limits we need to keep certain limits. Then no need to update the error. That condition we need to write. Then only that weight updation will be stopped and it will continue only the forward propagation. That means if change in weight is less than or error is less than 0.1, no need to update the weights. In that case, there won't be any back propagation. So that is a stop condition to update the errors. In that way, we can terminate the program. Okay. So here in today's session, this slide we have seen in the last class. Also, till W6 star, W7 star, W8 star, that you need to find out. And these things we have seen in the last session itself. So in today's session, we will see the hidden layer to input layer. Just to remember the diagram in the first slide. So from input to hidden layer, there are four connections. Those four connections corresponding connection link weights are W1, W2, W3, W4. And from W1, W2 are connected to the hidden layer 1, and W3 and W4 are connected to the hidden layer 2, H2. So the diagram shows that the first diagram shows that W1, W2 and bias B1 at the between the input to hidden layer, bias B1 link. So these three will be connected to the H1 neuron, hidden neuron. So the netted H1 is nothing but W1 into corresponding input, that is nothing but X1, plus W2 into X2 plus bias B1 is nothing but net H1. Output H1 you will get it after net H1 processed through the activation function. That activation function here we have considered as sigmoid function. So in the sigmoid function, if we keep sigmoid function is nothing but 1 by 1 plus e power minus x. So that 1 by 1 plus e power minus x is nothing but e power minus of x is nothing but here net h1, where is the input. So that is nothing but net h1 will be treated as an input. So after that net h1 need to be processed through the activation function. Then you will get the output h1. In a similar way, it is at the H2 neuron also. At H2 neuron, W3, W4 are the connection link weights from the X1 and X2, and bias B1 is connected again. So the corresponding net H2 is nothing but W3 X1 plus W4 X1 and W3 X1 plus W4 X2 plus B1 is nothing but net H2 at H2 neuron. Just to see that diagram, then in the first diagram, then corresponding output at H2 will be, it is equal to 1 by 1 minus e power, 1 by 1 plus e power minus net H2 is the output at H2 neuron. Okay, so here again, like in the previous slides, so here also we need to find out the dou E total with respect to the partial derivative of total error with respect to the weight W. Then we can update the corresponding connection link weight W1. In a similar way, we need to do it for the dou E total by dou W2 also. Dou E total by dou W3, dou E total by dou W4. But in this lecture, we'll see only one thing, that is dou E total by dou W1. The remaining thing you do it as a homework. In a similar way, you need to do it for the remaining connection link weights, that is W2, W3 and W4. Okay. So here dou E total by dou W1, it can be rewritten as per the calculus chain rule, like dou E total by dou out H1, because error will be at the output. That output upon out at H1 neuron output, then out H1 upon net H1, net H1 upon connection link weights, that is W1 or W2 likewise. So that's for the chain rule equation. Dou E total by dou W1, error, total error at the output O1 and O2. Dou E total by dou W1, E total is nothing but total error with respect to the dou W1 is can be rewritten as dou E total by output at the H1 neuron, that is nothing but dou E total by dou out H1 into dou out H1 with respect to the dou net H1, one on another from output to input, like error on out H1, see the diagram, error on out H1, out H1 on net H1, net H1 on W1. So by using that, dou E total by dou out H1, dou out H1 by dou net H1, dou net H1 by dou W1. If you cross all those things, then you will get at the end dou E total by dou W1 only. But that we rewritten as in terms of 3 terms. Again, to find out that dou E total by dou out H1, that can be rewritten as dou E total. Total error can be split into the 2 errors, that is error at O1 neuron, error at O2 neuron, output neurons. O1 and O2 are the output neurons, right? Dou E total by dou out H1 is equal to, I am splitting into the 2 terms, that is dou EO1 by dou out H1 plus dou EO2 by dou out H1. Denominator is same, only numerator will be addition of 2 errors at the O1 and O2 neurons. So again, the dou E O1 by dou out H1 can be split into the 2 terms. That is nothing but dou E O1 by dou out H1 can be rewritten as dou E O1 by dou net O1, error with respect to the net O1, that is nothing but input at the netted input of at the output neuron O1. Dou E O1 by dou net O1 into dou net O1 by dou out H1. So here dou out H1. H1 is the hidden layer output. Hidden layer output is connected to the output neuron. So dou E O1 by dou net O1 into dou net O1 by dou out h1. In a similar way, dou e o2 by dou out h1 also can be rewritten as dou e o2 by dou net o2 into dou net o2 by dou out h1. Okay, again the dou e o1 by dou net o1 can be split into two terms. That is, dou e o1 by dou net o1 is equal to, if you see the next step, dou e o1 by dou out o1 into dou out o1 by dou net o1. So instead of, as we don't get the direct partial derivation with of e01 with respect to the net o1, we are split it into the another two terms, that is dou e01 by dou out o1 into dou out o1 by dou net o1. In a similar way, dou e02 by dou net o2 also split it into two terms, that is dou e02 by dou out o2 into dou out o2 by dou net o2. So now we know we have all the partial derivatives with respect to the denominators, so we can substitute the values. If you see that, I will see the right side term first, that is dou e o2 by dou net o2 is there. Below that we have dou e o2 by dou out o2 into dou out o2 by dou net o2, right? So if you see that one, with respect to the output neuron, o2 will see first, then in a similar way we can do it for the o1 neuron also. So the right side term is dou e o2 by dou out o2. So the same term derivative have considered on the left side box. If you see below that diagram, between those two diagrams we have dou e o2 by dou out o2, which is equal to error with respect to the output o2, right? Which is nothing but output minus target. Actual output at the o2 minus target is nothing but the output o2 minus target o2. So if we do that, output o2 we know, actual output how much we got it, then target output how much we had it, actual output we had already calculated in the last slides, and target output already it has given in the first figure itself. If you do that, you'll get the, if you substitute those values are 0.772928165 minus 0.99. It will give 0.2170711535 is the dou e o2 by dou out o2. So what is the another term beside the dou e o2 by dou out o2? It is dou out o2 by dou net o2. Dou out o2 by dou net o2 is nothing but, even if you see the derivation of back propagation algorithm in the last but one class, I think on 20th lecture, we have seen the derivation of back propagation algorithm, right? There if you see that actual output by netted output or netted input, that is nothing but, you'll get if you see the derivation, in the derivation also we got pi dash of vjn. Vj of n is nothing but netted input, yj is nothing but actual output, dou yj by dou vj of n is nothing but activation function differentiation. In the derivation we got it. Here also you need to do the activation function differentiation, that is nothing but dou out 2 by dou net o2 will give the activation function different, because dou net o2 is nothing but dou out 2 by dou net o2 is nothing but differentiation of activation function with respect to that x term, 1 by 1 plus e power minus x. Here x is nothing but net o2. If you differentiate that one, you'll get in the left bottom corner that out o2 minus out o2 into 1 minus out o2, that you'll get it. Here out o2 is nothing but 1 by 1 plus e power minus x into, in bracket, 1 minus 1 by 1 plus e power minus x. Just otherwise you can see the differentiation of sigmoid function. Differentiation of sigmoid function you will get it as 1 by 1 plus e power minus x into, in bracket, 1 minus of 1 by 1 plus e power minus x, you will get it. 1 by 1 plus e power minus 6 nothing but again output O2 only. That's why out O2 into 1 minus out O2. Already output at the O2 neuron we have calculated in the last slides. Those values if you substitute you will get the value as 0.175510052. So now you have to multiply these two values, which is nothing but point that is dou e O2 by dou out2 into dou out O2 by dou net O2, which is nothing but 0.217071535 into 0.17551052. On the left side we have two values, right? Those two values if you multiply you will get the corresponding value as minus, in the box I have given minus 0.0380982. You will get it. That is with respect to the dou e O2 by dou net O2. And what is the beside term for the dou e O2 by dou net O2 with respect to the output neuron? Dou net O2 by dou out H1 on the right side. Dou net O2 by dou out H1. So if you want to find out that net input at the O2 neuron is nothing but, if you see the left bottom side you have one figure, half of the actual figure, hidden layer and output layer. So H1 is connected with respect to the output O1 as well as output O2. The corresponding connection link weights are W5 and W7. What is net O2? Net O2 is nothing but W7 into output of H1 plus W8 into output of H2 plus bias B2 between that hidden layer and output layer. So net input at output neuron O2 is equal to, just to see the diagram in the left bottom corner, net input at output neuron O2 is equal to W7 into output at H1, W8 into output at H2 plus bias B2. Now in that term, what is the differentiation? Differentiation with respect to the output at H1. Remaining all are constant, remaining two terms, that is bias B2 and output at H2 are constant. That's why those two terms will be 0. Only you will get, you have one term that is W7 into output at H1, right? When you are differentiating that, you will get only W7. Dou net O2 by dou out H1 is equal to W7. W7 value already in the first figure we have given, that is 0.50. In a similar way, we can do it for the O1 neuron also, which is before that plus symbol is there, right? So dou e O1 by dou net O1 into dou net O1 by dou out H1. That also we can do it in a similar way like the O2 neuron. If you do that, you will get those values also. Here W7 you got it, there you will get the W5 because that is with respect to the H1. Dou net O1 by dou out H1, right? What is net O1? Netted input at the O1 is nothing but W5 into out H1 plus W6 into out H2 plus bias B2. So out H2 and bias B2 are constant with respect to the out H1. Only when you are doing dou net O1 by dou out H1, you will get W5 as a constant. That value you know. The remaining term also you can calculate in a similar way to the output neuron. So now if you multiply the W7 with dou e O2 by dou net O2, you will get the term as minus 0.0190491119, the last but one line in the equation dou e total by dou out H1. And if you multiply the W58 with the dou e O1 by dou net O1, that is nothing but 0.138 49856 into 0.9, you will get 0555399 If you add those things, you'll get dou E total by dou out H1 as 0.36350306 as dou E total by dou out H1. That is one of the only first term in the first equation. What is the first equation of this slide? Dou E total by dou W1, right? In that first equation, first term is nothing but dou E total by dou out H1. That term you got in the last. So the remaining two terms also we need to find out. Then we can find out the dou E total by dou W1. For the remaining two terms, so what is the overall equation? Again here I have written overall equation, that is dou E total by dou W1 is equal to dou E total by dou out H1 into dou out H1 by dou net H1 into dou net H1 by dou W1. Here dou out H1 by dou net H1 is nothing but differentiation of activation function. That is nothing but out H1 minus out H1 into 1 minus out H1. That is nothing but here out H1 I have written is 1 by 1 plus e power minus x can be written as activation function, right? That is nothing but out H1 only. That's why out H1 I have written. So if you substitute those values, you will get the dou out H1 by dou net H1. That is equal to 0.2413000709. Next, what is the third term? Third term is nothing. Third term in the first equation is dou net H1 by dou W1. So to find out that net H1 is nothing but if you see the first diagram in the left top corner, net H1 is nothing but W1 into X1 plus W2 into X2 plus B1, right? Into corresponding connection link with 1, B1 into 1. So if we differentiate that with respect to the W1, dou net H1 by dou W1, you will get remaining terms, second and third terms are constant, so it is equal to 0. W1 X1 differentiation with respect to the W1 will be the X1. X1 value already we know, that is 0.05. In the first problem statement itself it has given. So now the first term already we have calculated in the last slide, that is dou E total by dou out H1 on the left side we have, which is equal to 0.036350306. You need to multiply with the other two terms, that is dou out H1 by dou net H1, which is equal to 0.2413000709 into dou net H1 by dou W1, it is equal to 0.05. If you multiply all three together, then you will get dou E total by dou W1 as 0.000438,568. Now you have dou E total by dou W1. As per the delta rule, what is the change in weight? Change in weight is nothing but minus neta, learning rate parameter, into differentiation of error with respect to the corresponding connection link weight. So if you add the same as per the delta rule, the change in weight, if you add it with the corresponding connection link old weight, then you'll get the new weight. That is nothing but W1 star is equal to W1 minus neta into dou E total by dou W1. So that minus neta into dou E total by dou W1, we got it from the delta rule. So we have seen in the derivation. So if you add that with respect to the, if you add that same term to the old weight, then you get the new weight W1 star. So already old weight is 0.15 minus neta, learning rate parameter, what we have taken earlier. Here also we are considering it as 0.6. The same learning rate parameter between hidden to output neuron output layer, we have considered 0.6. Here also we are considering it as between input to hidden layer, also we are considering it as 0.6. And dou E total by dou W1 we have already calculated. That value we can substitute as it is. Then you will get the W1 star, that is nothing but updated weight W1 is equal to 0.1497368592 as the W1 star. In a similar way, you can calculate the W2 star, W3 star and W4 star also. This you do it as a homework, and these two slides you write it step by step, then only you can understand. So to have all the values I have taken in the single slide, but You do it step by step, that you take it as a homework and find out the double 2 star, double 3 star and double 4 star. So now you got all the updated weights from W1 to W8 as W1 star to W8 star. For these updated weights, again you will get the new error. That new error, if it is not within the limits, within the prescribed limits set by the user, then that error need to be again back propagate. When it is back propagate, again the connection link weights from the W1 to W8, again it will be updated as per that connection updated link weights. Again new error you will get it. That new error, if it is not within the limits, again back propagation, forward propagation, calculate the error, back propagation, update the weights, forward propagation, calculate the error, back propagation, update the weights, forward propagation, calculate the error. So this is continuous process. It can repeat thousands of times. In this process, if that error reaches or error you can find, if you find within the prescribed limits, then you can terminate that program. Otherwise, this process will continue. That error limitation or limits for that error need to be decided by the user. So, for example, if E1 need to be within the, let us take E1 should be within the 0.005. E2 should be 0.003. If it reaches below that 0.005 and 0.003, then it will not update the total error, right? Total error is nothing but 0.008. The total error, if it is below 0.008, then it will not update the error. There won't be any back propagation. The corresponding connection link weights will not be updated. Those weights are the correct weights as per the user requirements. That can be understood by the program. Then it will give the actual outputs. That at least it will give the close to the desired output. Okay. So this is about the back propagation algorithm with a numerical example. You need to solve step by step. You need to follow these slides and as well as video and put it on paper. Find out the W1 star to W8 star for one iteration at least, and then you can understand very clearly. Even you can get multiple videos in the YouTube also to understand very well. Okay. Thank you all.